All right, so let's continue section 9.3. We're talking about logs. All right, and what I want to do is I want to use our definition that we talked about last time to help us with these. All right, so right now, what form do we have here? What form is this? Log form, right? So yesterday it was helpful to go from log form to what? To, what was that? Remember? Exponential form, right? So let's do that. So this is log form. This is log form. So let's see if it's helpful in this case to go to exponential form. All right. So when I look at this, what's my base?
8.
Good. So my base is 8. And again, I don't know what this is equal to, so I could say x or y or a, some variable. All right. So I have 8 raised to what power here? Good. 8 raised to, this guy's my exponent over here. And this is equal to, what do we have it equal to? 1 over 64. All right. Good. So today I want to hint on a few things. So number one, this piece right here is a fraction. So what does that tell us about our exponent? It's going to be what?
Negative.
It's going to be negative. Does that make sense?
Yes.
All right. If it doesn't, get out. Okay. So, all right, when this is a whole number and it equals a fraction, that's giving us a big hint that we're going to have a negative exponent. So make sure you write that down. All right. If you're watching at home, write that shit down. So we have a negative exponent. So what you're thinking about is 8 raised to what power gives me the 64? Negative 2. I could just watch. So I could imagine like a young, smart 10-year-old like getting advanced. He's like, this guy just told me to write that shit down. All right. So it makes sense right there? Cool. Questions? All right, let's continue. All right, number 2. We'll call this part A. We'll call this part B. All right, a log base 64 of 2. Log base 64 of 2. Again, we're going to evaluate this. So again, I don't know what this is equal to. Let's just get in a habit of using different variables, just so you don't get like, oh wait, I don't have x in this one. Doesn't matter, right? It's a variable. All right, so we rewrite this using our definition. So we're going from log form to exponential form. Good. So this, I could rewrite it as what?
64.
Good. 64.
Exponent of x. Right. Oh, my bad. A, yeah.
Okay, yeah, good. Or x, right? If I write x. And it equals what?
2.
2. Oh, this is the first time we've seen something like this. Because notice, we're going, our base is a pretty large number, but now we're going backwards. We haven't seen anything like this before. It's going back to a small number. So what I want to do is I want to think about what's the relationship. So we're going to put pause right here on that question. All right. So don't write this down, but I want you to think about this. How would I go from, say, 64 to 8? What would I need to do to that 64?
Square root it.
Square root it, right? What's the exponent of a square root? Not 2. That'll make it bigger, right? 1 over 2, right? That's how I'll go from here to here, right? Let's say that I have 27 and I want to get 3 as my answer. 1 over 3, right? Because isn't that the cube root? So I'll be 1 over 3. So now that I have 64 and I want to get 2, so I already know it's going to be 1 over something. So what I want you to think about is 2 times itself. How many times will give you 64? So 2 times 2, that gives me the 4 times the 2. Good. So what'd you get? 6, right? So if you do 2 times 2 times 2 times 2 times 2 times 2, that's what gives me 64. So whenever our base our original base that has an exponent is larger than our outcome, this is what's gonna take place. We have to either take a square root, a cube root, a fourth root, a fifth root, some type of root. So A has to be, what in this case? Not 6, because that would make it huge. 1 over 6. Alright, so we're gonna use that logic today. Alright. Let's be even more creative. Alright, let's look at these right here. So let's be a little bit more creative. We're gonna go beast mode here. Alright. We're gonna go pi mode. Like that. So one of my former students, he has a little shot, so he made me the shirt. Pretty sick, huh? Alright. This one, it looks complicated. It looks complicated. But if you use the ideas that we just talked about, it's not gonna be bad at all. So first thing, I'll set it equal to, since I have a pi share, p. Alright, so let's rewrite this. How do I rewrite this? What's my base?
2.
2. Raised to what power?
P.
P equals what?
2 exponent 7.
Good, 2 to the 7. And we talked about something very important yesterday. We said if the bases are the same, then what?
Exponents are the same.
The exponent's supposed to be the same. So write that down in case you forgot. If our exponents are the same, if our bases are the same, then our exponents supposed to be the same. So we know that P now is equal to what? 7. Cool? Alright. So again, using these properties that we discussed yesterday, pretty powerful stuff. Alright. So let's go with log base 5 of 1. Log base 5 of 1. Alright, so let's rewrite this. I'm not going to set equal to anything. I'll let you guys decide. How do you want to rewrite this? That's one idea. Let's get another one. 5.
Exponent x
Good.
equals 1.
Right? So same thing. And if it helps you, if it really helps you, just go ahead and set it equal to x. Just so you know, this is my base. Look at the little diagram I'm going to do for all you nursing majors, because they use a lot of diagrams and acronyms and all these tools to memorize things. This is my base. Sound effects. There's my exponent. And it equals, right? It equals that 1. So it always goes like that, full circle. So let's think about this. 5 raised to what power equals 1? 0. Because anything raised to the power of 0 gives 1. Alright? So x must equal 0. Alright. Excellent, excellent. So questions. Alright. Let me give you something that I did not discuss yesterday on purpose. Alright. So let's go with E. Here's a problem child. Alright. So if I wrote down, don't copy this down, but if I wrote down the variable x, what's my exponent right now?
X. 1.
The exponent's 1, right? If I wrote down the square root of x, what's my index? That's invisible. 2, right? If I wrote down the variable x and I ask you for the coefficient, the number in front of there, what's the number in front? 1. So we have all these unwritten rules, right? So for logs, whenever you do not see the base, whenever we don't have the what? The base, we make an assumption. Alright, so whenever you don't have the base, this is the same thing as log base 10. So whenever they don't give you the base, whenever they don't write down the base, then it's base 10. That's a definition right there. Whenever they don't give us that base, you know it's 10. Yes.
Is it always 10, or if the 10 was a 9, would it be 9?
So today's the 3rd, so just today. No. So, good question. It's always gonna be 10, even on Sunday. Good. Yeah. Because, again, good idea, because sometimes as you move on in math, right, there's gonna be some instances where these rules change, so, good question. But luckily for us, this always holds true. Right? Cool. All right, so now let me use this. Let me use that little fact, that little fun fact right there. That's gonna make this way easier now. Because now when I rewrite this, my base is 10, my exponent is x, and this equals what? 10. And we said earlier, if I don't have an exponent, this exponent is 1. So now I know that x equals what in this case?
1.
1. X equals 1. Cool.
If the numbers are the same, do they just cancel themselves out?
Ooh, she's trying to show off our YouTube.
Because earlier in where you have
Yeah.
the 2's, they canceled out as well.
Yeah, that's an excellent question. And actually, that's where we're headed. So we're gonna talk about properties of logs. That's what we're doing right now, actually. Good, and that's our first property. Nice, good. So this is homework. We're gonna look at homework number 44. And we're gonna look at all these various properties of logarithms. All right, so let me give you, I'll just call them property number 1.
Yeah.
Later on, we'll give them names and stuff, but just for the sake of notes, it'll be easy right now. I could just put them in order. All right, so in this question, let's see. Let's put an X right here and an X right here. So her question was this: if these guys are the same, do they cancel out? So when this was a 10 and this was a 10, what do we end up with our answer? 1. And before, I think I erased it. Oh, like these 2's, that's what you were saying. These 2's cancel each other out, right? And it left you with that exponent. So good, you were right. So there's our first property. Whenever these are the same, the base, and this guy's called, so let me write this down. This is our base, because we said it many times. It's all about that base, about that base, about that base. And this is our argument. So that's our argument. Some of you are great at that. Alright, so we have a base, we have an argument. Whenever the base and the argument are the same, what we're left with is the exponent. In this case, the exponent was what? 1. So this was our exponent. This exponent that was right here. Alright, so let me rewrite this. So now we can get into all the shortcuts, because now we're gonna have a bunch of properties that we can use. So let's go with this first example for this property. Let's go with log of 7, log base 7, and let's say our argument is 7 raised to the 9th power. So what I could do if I wanted to do this the long way, I could go ahead and change it from log form to what? Exponential form. That'll take me to the promised land. But I have this cool property now, and I'm like, what's gonna happen with those 7's kind of? They cancel, and I'm left with what?
9.
Just a 9. So that's a nice, useful property. Alright, excellent. So that's our first property right there. And we saw that happening before. Cool, so good eyes. Next. Let's go with, let's reverse this a little. Property number 2. I'm gonna change the order. Again, we'll give them names a little bit later. So let's say we have P is our base, and this one's gonna look funny, so make sure you copy this property. So our base is P, and our exponent is gonna have a log in it. So it's gonna be our base P, our exponent has that log in it, so log base P. Alright, this one's gonna make you drop your phones. And then let's say I have, I don't know, my argument is B. Alright, what do you imagine is gonna happen here if you had to take a guess? You just had to take a guess.
You're gonna cancel out.
They're gonna cancel out the P's? Nope. Not, you're good, yeah. These guys cancel and it just leaves you with that B. Good. So we're gonna use this property quite often as well. Alright, so let's see an example of this in action. So let's see an example of this property. Let's go with 8 is our base, so make sure you write that as your base. And then let's go with log base 8. So make sure the base, you write it small so you don't get confused in your notes. And our argument is 5. So here we already know what's gonna happen with the base and the two bases. Good, it cancels and gives you 5. Dang. Alright. So questions on any of those two properties so far?
What if we're not given, an argument?
What if you're not given the argument? So here's a great thing about logs. Whenever you have logs, good question, they have to give you a base. They might not write it, but we know the base is what if they don't write it? 10. And the argument, they always have to give it to us. Later on, we're gonna see the argument's gonna get a little bit complex, but these two things are always given. Alright, that's what makes up a log. Cool. Okay, let's get fancy here. Let's get fancy. Let's go with property 3. All right. So let's say I have a log of any base, and I say here that your argument is 1. So anytime your argument is 1, I'm gonna get some type of answer. So remember what we're looking at. I'm trying to think about b raised to what power? B raised to what power is gonna give me an answer of 1? 0, right? So anytime your argument is 1, your outcome is gonna be what?
0.
0. Right? See, he's excited. Alright, so anytime your argument is 1, bam. So let's do an example. So log base 1 over 5. So log base 1 over 5 of 1. So notice I'm throwing parentheses in there. I don't need them, but I'm trying to get you comfortable with writing them with and without parentheses. And then we'll get into, hey, when does it help to write them? When does it help not to write them? What do I get here for my outcome? 0. Alright, so easy? No? A lot of properties? Let's do another example. So now I'm gonna mix up on my properties, so get ready for this. We're gonna put them all together. So you're gonna get these logs. They're gonna get longer and longer and longer, but as long as you know and you understand these properties, it's not gonna be bad at all. Alright, let's just go there. So let's see how understanding these properties is gonna make this really easy. Alright, so first of all, what do you notice about this first term here? There is a base, right?
Oh, right.
Good. It's not written, but we know it's a 10. So these two are the same. So what's
6.
good? They cancel, and we're left with 6. Nice. These two are the same. So they cancel, it's gonna leave you with what? Be very careful. A 1, because our exponent is a 1. Damn, so that's the same thing as 7. Alright, so it's cool. You know how they have like the child care center here? So one of my first semesters teaching this class, I had a few of my students in the class, and they were at the daycare where my son was. So you know, the daycare, you check your kids in and you write down the time, so I would put and they were like, what the fuck is that guy doing? And then the lady in charge, my students would be laughing because they knew what I was doing, right? And then the lady in charge would be like, what is this? I was like, wait, you can't do this? I was like, I don't know if I want to bring my son here. Alright, here you go. Actually, before we get another example, I want to talk about some more properties. And I want to look at expanding logs. And again, where we're headed is we have to nail all these properties because we want to get to a place where we're able to solve logarithmic equations. We want to solve exponential equations. So right now we're just gathering all the tools so later on we could perform those things right there. We want to be very efficient. And there's going to be different techniques. But again, if you got these down, oh my God, it's going to make life easier. Alright, so let's talk about these properties of expanding logs. So here's the first one, I'll call it A, for expanding logs. Let's go with log base B, and let's say I'm multiplying, I have two things being multiplied, two factors in my argument, an x and a y. So the properties of expanding logs, what they tell us that I could do, our multiplication rule, again we'll give them names later. It says that I could separate this, and this multiplication, when I separate them, is going to turn into an addition. And there's a common mistake that people make when they separate them. So notice I left something out. I want to do it in a different color to emphasize. What did I leave out?
The base.
You can't forget that base. So this base, make sure whatever this base is, you write it in both of those. So this one log turned into 2. And you're always going to know because of the number of factors that you see in here. So if this had 3 factors, how many logs would it have?
3.
3. Right. Part B. So just like I can multiply, we could go ahead and we could divide. Right? So when we divide, if the multiplication led to an addition, then we could assume that the division is going to lead to what? Subtraction. So it's going to lead to subtraction. And again, just to emphasize this, I'm going to write down my base in a different color just so we know, can't leave it out. Alright. So how is this going to be helpful? So there's going to be problems in the homework, and again, we're going to use this a lot when we're solving logarithmic equations, where they're going to ask you to expand these logs. Alright? And they'll give you something like this, log base 3 of 4r. And all they're going to want you to do is to rewrite this in expanded form. So according to what we just copied down, our properties here, this is going to turn into log base 3. What's my first factor?
4.
4. And then what do I write down next?
Plus.
Plus
Log R.
log base 3 of r. And that's it. So all we're going to be doing is applying these properties. Yes?
Why would they not be together if between the 4 and the r there is no like multiplication or? Because in the first one there was like
Let me ask you this.
yes.
4r, is that the same thing as 4 times r?